NEC Section 430.74c addresses combination motor controllers. It states that combination motor controllers must be listed and marked with their circuit diagram. This diagram should illustrate all component parts of the motor controller and its internal wiring. This requirement emphasizes the importance of having a clear understanding of the controller's internal configuration for safety and maintenance purposes. NEC Section 300.3c deals with the installation of electrical equipment. It specifies that electrical equipment should not be installed in a way that exposes a live conductor to an enclosure likely to be energized by an adjacent circuit. An exception exists if the enclosure meets the conditions for exposure to other circuits of 50 volts or more, as detailed in Section 300.4. This rule aims to prevent accidental energization of enclosures, which could create a hazardous situation for personnel working on or near the equipment. NEC Section 300.4 focuses on the installation of different electrical systems within a common enclosure or compartment. It mandates that while live parts of different systems are installed in the same enclosure or compartment in such a way that accidental contact is possible, the grounded parts of these systems must be bonded together electrically. This bonding is essential to minimize the risk of electrical shock by ensuring that all grounded parts are at the same electrical potential. Based on these NEC requirements, the proposed arrangement involving separate power sources without a transformer for the control circuit may not be compliant. Firstly, the control circuit is recommended to be powered from the same source as the motor circuit. This ensures that the disconnect for the motor controller also disconnects the control circuit, adhering to the requirements outlined in Section 430.74c. Secondly, there's a potential for accidental contact between live conductors of the 480 volts and 120 volt systems because they are housed in the same enclosure. This violates the guidelines provided in Section 300.3c. Thirdly, the grounded parts of the two systems must be bonded together electrically to prevent differences in electrical potential, which aligns with the provision stated in Section 300.4a. The use of a transformer in a combination starter assembly ensures that the control power is derived from the same source as the motor power. This arrangement simplifies the control and enhances safety because the main disconnect for the motor also de-energizes the control circuit. This concept is very important for de-energized maintenance. Consider a scenario where the motor is fed from a 480 volt three-phase supply and the control circuit operates at 120 volts. If these voltages are supplied from two separate panels, then the control circuit would remain energized, even when the motor disconnect is opened. A transformer steps down the 480 volts to 120 volts for the control circuit. The primary side of the transformer is connected to the same 480 volt supply as the motor. Therefore, when the motor disconnect is open, both the motor and the control circuit are de-energized. Regarding overcurrent protection, both the motor and the control circuit require overcurrent protection devices such as fuses or circuit breakers. For the motor circuit, overcurrent protection is sized according to the motor's full load amps and starting characteristics. For the control circuit, overcurrent protection is sized to protect the control transformer and the control circuit wiring. Control circuit transformers are sized based on the volt-amp requirements of the control circuit components such as relays, contactors, and pilot lights. A transformer's volt-amp rating should be sufficient to handle the total volt-amp load of the control circuit. For example, if the control circuit consists of several relays and pilot lights, the total volt-amp requirement is calculated by summing up the volt-amp ratings of each component. The transformer should be selected with a volt-amp rating equal to or greater than this total. Control circuit wiring is selected based on the ampacity of the wires needed to carry the current drawn by the control circuit components. The wire gauge should be sized to handle the maximum current that the control circuit can draw. It is important to refer to the NEC tables for ampacity ratings of different wire gauges and insulation types. Control circuit protection is provided by fuses or circuit breakers installed in the primary and secondary sides of the control transformer. These overcurrent protection devices protect the transformer and the control circuit wiring from overloads and short circuits. The primary side of a current protection is typically sized at 125% of the transformer's primary current rating, while the secondary side of a current protection is sized to protect the control circuit wiring. Control circuit components include relays, contactors, timers, and pilot lights. Relays are electromagnetic switches that are used to control circuits. Contactors are heavy-duty relays used to switch motor circuits. Timers are used to introduce time delays into control circuits. Pilot lights are used to indicate the status of the circuit. These components are wired together to form the control circuit, which controls the operation of the motor. Control circuit design involves creating a schematic diagram that shows how the control circuit components are wired together. This diagram should clearly indicate the function of each component and how they interact to control the motor. The schematic diagram should also include the ratings of each component, such as voltage, current, and horsepower. Additionally, the schematic should include the wire sizes and types used in the control circuit. Control circuit troubleshooting involves using electrical test equipment such as multimeters and clamp ammeters to diagnose problems in the control circuit. Common problems include open circuits, short circuits, and grounded circuits. When troubleshooting, it is essential to follow safe electrical work practices, such as energizing the circuit before working on it and using appropriate personal protective equipment. Control circuit maintenance involves periodic inspection and testing of the control circuit components to ensure that they are functioning properly. Maintenance tasks include checking wire connections, testing relays and contactors, and replacing worn or damaged components. Regular maintenance can prevent unexpected failures and extend the life of the control circuit. Control circuit modifications may be necessary when the motor or the equipment it drives is upgraded or modified. Modifications may include adding new control components, changing the wiring, or upgrading the overcurrent protection. Any modifications to the control circuit should be performed by qualified personnel and should comply with all applicable electrical codes and standards. When working with combination starters, safety is paramount. Always to energize the starter before performing any maintenance or troubleshooting. Use appropriate personal protective equipment, such as safety glasses, gloves, and insulated tools. Follow lockout-tagout procedures to ensure that the starter cannot be accidentally energized while you are working on it. Understand the circuit, especially the control voltage in relation to the motor voltage. The use of a control transformer is very common when the motor voltage and control voltage are different. Having separate sources is possible, but the safer route is to derive the control power from the same motor power source. Also, motor starters, including combination starters, are required to be listed.